This question is from GATE 2015, Mechanical Engineering paper, set 1, question number 46. A horizontal plate has been joined to a vertical post using 4 rivets arranged as shown in the figure. The magnitude of the load on the worst loaded rivet in Newton is dash. Now in this figure, if we have to mark the CG of these 4 rivets, we can mark it here at 20 mm being this distance and 20 mm being this distance. We have just taken the half of the distance between the rivets that is given. So this will be the CG. All rivets are placed radially equidistant from the CG. Now from the CG of this arrangement of rivets, the distance of load is 500 millimeters, which is given. So this load will apply 2 forces on the rivets. One is the direct shear and another one is the shear due to the torque created by 400 Newton, because this is at a distance of 500 mm from the CG of the joint. First we'll calculate the direct shear on each rivet. Direct shear, let this be rivet 1, 2, 3 and 4. So if we write direct shear as PD, we have P1D is equal to P2D is equal to P3D is equal to P4D. All of the rivets divide the load equally among themselves. So we have this as 400 divided by 4, which is 100 Newton. Now comes the shear due to torque. So we can write shear due to torque. Let that be PT. Now how to find this? We know that torque developed is 400 into 500 mm becomes 0.5 meter. This torque is also equally divided among all the rivets, but in the form of shear force that is acting tangential to this line connecting CG and the center of the rivet. So if we draw the assembly like this, and this is the CG of the arrangement, we can see that this is the line connecting between CG and the center of the rivet. So shear due to torque will act perpendicular to this line. Same is the case with all the rivets. Let's mark the direction of shear due to torque, and here it is. This torque is being divided equally in all rivets, so we can divide it with 4 is equal to. Every rivet will produce a force due to this torque acting on it, and this force into the radial distance will give the torque on the individual rivet. So we can write P1T into R1. So P1T into R1 gives us the torque that is taken by this rivet. So finding out P1T, first we'll find out R1. To find R1, we can use the geometry given here. So this is 20, this is given as 20. So this is 90 degrees. So the remaining angles will be 45 and 45. We can find out R1 from this triangle, which is root over 20 square plus 20 square, which is nothing but 20 root 2. So R1 is 20 root 2. Let's put it here to find out P1T. We have P1T as, so on this side we get 50 divided by 20 root 2. This value is in millimeters. We will have to convert it in meters because the torque we calculated is in Newton meter. So into 10 to the power minus 3 gives us P1T as 1767 Newton. This is the force due to torque, shear force due to torque on rivet, and earlier we have calculated the direct shear is 100 Newton on each rivet. So if we calculate the resultant force on every rivet, that is if we calculate FR, which is the resultant force on every rivet, is equal to, it is given as root over direct shear square plus shear due to torque square plus 2 times direct shear into shear due to torque cos theta. This is the general formula for calculating resultant on any member if there are 2 forces acting on the same plane. Now we will have to decide. We have values of PD and PT for every rivet, but we don't have the value for theta. How is theta calculated? So for this one, for this rivet, if we plot a free body diagram here, the forces acting on it are, one is the direct shear P1D and another is the shear due to torque P1T. Angle between them is nothing but theta. if we are to determine theta in the first rivet case, how will we determine it? This angle is given to be 45 degrees and we know that this is 90. So theta is ultimately 45 degree, because 90 minus 45 gives us 45 degrees. For first case, it is 45 degrees. For the second case, same thing, it will be 45 only. For the third case, however, it will be 90 plus 45, which is 135. And for the fourth case, it will be same thing, 90 plus 45, 135. So we either have theta as 45 or theta as 135. Theta can be 45 degree or 135 degree. We are using cos theta in the resultant formula. So cos 45 will give us a positive value that will add up to the sum of these first two. And therefore we will get a greater number. As opposing to cos 135 degree, which is a negative value, which will subtract some amount from the sum of the first two terms. So this will give us a lower value, but 45 degree angle will give us a higher value. We have to find the worst case of shear, and that is why we will use theta as 45 degree. So FR is equal to root over PD is 100 square plus PT is 1767 square, 1767 square of it plus 2 times 100 into 1767 into cos 45 is 1 by root 2. So this comes out to be FR is 1839.84 Newton. Let's fill in the answer. Magnitude of load on worst loaded rivet in Newton is 1839.84 Newton. To learn more about such eccentric connections of rivets, you can refer to the NPTEL video Lecture 13, Eccentric Connection, Load Lying in Plane of Bolted Joint, from the course of Design of Steel Structures. It is by Professor Damodar Maiti. He is from IIT Kharagpur, Department of Civil Engineering. I hope this solution will help you clear your doubt. Thank you.